Hey everyone, Mr. Newman here. Today we're going to learn how to model with the quadratics that we've learned how to graph. So you're going to need your graphing calculator for the second part of this video, so go ahead and grab that. First off, I want to show you guys, and I'm going to turn the paper this way so we can see it all. I want to show you guys what this is. This is called a link sheet. Notice the instructions that all four of these are modeling the same problem. We have an equation, a description, a table, and a graph. And I filled out a lot of it on this first one for you. You're going to fill out more of it on the second one with my help through the video. But I want to show you guys this because I want you to notice how all four of these are connected. And for example, those questions in the description, we can answer those using the equation, table, or the graph. So let's get started. First of all, the situation is a basketball is thrown through the air. The horizontal distance in feet is x, and that affects the height in feet, y. Both are represented by the equation, table, and graph. The first question is, first thing we actually have to do is notice I did not finish filling out this table down here. So we need to use our graph to fill out the table. So notice on the graph, 0, 5 is the point right there, 1, 8 is the point, the purple point right there, and 2, 9 is the point right there. I could plug 3 into the equation here. I could do this and plug it in up there and get out an output, a height. Or I can just look at the graph here. Notice when I look at the graph, if x is 3, that point right there is 3, 8 on the graph. So my output is 8. We can do the same thing for 4, where the input is 4 and the output is right there. So 4, 5 is the point, so the input is 4, the output is 5. I can also do this for the point 5, when the horizontal distance is 5, the ball is right there, so that's 0 feet up, so the height is 0. Those points I can also get by plugging into the equation, though I'll show you that another day, but it's basically inputting the x and outputting, getting out the y values. Now, one thing I want to show you about this is, as we answer this, this question here, I want you guys to notice how that span of values, those points, cover the entire graph. Notice they're not all scrunched up on one side. Instead, the points, there are 6 points there, they spread out across the graph and they fill up the graph. That's part of a link sheet where you want that span to match the domain, that's the x values, and the range, that's the y values, of the entire graph if possible. So, let's get started. What height was the ball released? Well, the ball was released on the left side there, right there where I circled in red. That height is 5. You see the number there. Oops. And I want to show you guys, I'm going to draw it out real quick what it looks like to have thrown the ball. I'm picturing the ball being thrown and the ball goes up, 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 up. And then, so it's increasing at first, and then descends or is decreasing down on the right side there. And it ends on the floor on the right. So at what height was the ball released? Well, it's released right there at a height of 5 feet. You can also see that in the table. See where the horizontal distance is 0? The height is 5 feet. So write down 5 feet. What's the highest the ball gets? Oh, I got it from feet from both in the situation and from the table. Well, what's the highest the ball gets? We could look at the table there. You see the numbers 5, 8, 9, 8, 5, and 0. The biggest number there is 9, but we also want to double check that with the graph. Notice that that point 9 is the highest. That's also the biggest, that's the y value of the point at the very top of the parabola. We call that, remember, the vertex. So the vertex there is 2, 9. That means 9 feet is the highest the ball gets. How far has the ball traveled horizontally when it gets to that point? Well, horizontal distance is our x value, so you can look at the table right there and see the 2. Or if you write down the value of the point, 2, 9, 2 feet is the horizontal distance. So when the ball is 9 feet in the air, the ball is moved 2 feet to the right of the shooter. How far from the shooter does the ball hit the ground? Well, there's our 0. So when the height is 0, the x value, the distance, is 5 feet from the ground. So that is going to be on that point down there is 5 feet away. Now some people are going, wait, but that's not 5 feet away from where the ball was released. Well, I'm looking at how far is it horizontally. So if you picture the shooter being right here, it lands 5 feet away from his feet. Now that we've answered that, I want to point out one thing here. I'm going to take away a lot of the clutter. I want you guys to notice that on the table it says to label the headers. I did that for you. In the future, you will have to. So notice the x value is horizontal distance and the y value is height. If those are blank, we need to write those words down. And you can also write X and Y, but we need to be as detailed and specific as possible. Notice on the graph, it also says label the axes. I did that for you there as well. What I did not do, and you need to do, is I did not write the word feet. I did not label my units. So that's a part of labeling both the numbers and the units. All right. Let's look at the next section. And you notice there's no table and no graph, so we need to graph this on a calculator to get us started, and you are allowed to do that. So let's look at our calculator. I'm going to type that into y equals. Notice I used negative in front of the 4 instead of minus. If you press the minus button instead, you're going to get something, I think it will say syntax error. So negative 4x squared. And when you press graph, you'll get something that looks like this. Notice the kind of scrunched up parabola there. If you press trace, then you will get this. And notice it gives you the x-intercept, 0, 8. If we move to the right, and you try to get to the top of that, you notice, also 0, 8, we can put that in our table. Go ahead and write that down in the table as the first, leave space at the top, but write it for the headers, but put it as the first entry under the header there. If you go to the right, you notice I got x close to 1, but that spider is not at the maximum. So that means 1 is not going to be the x value of my maximum. That's kind of weird because 0 is not the maximum, 1 is not the maximum, but somewhere between those values is. Well, another day I'm going to show you guys how to calculate the maximum, but for today, I'm just going to share with you guys to make a guess. And halfway between 0 and 1 is 0.5, so I'm going to guess 0.5. Because when you press 1, notice that 1 enter does not, 1, 8 is not the maximum. The graph gets higher than that. The maximum, we are going to try a half, and I'm going to type in 0.5 for that. So you type in 0.5 and then press enter. And you notice the value it gives you is the maximum, 0.5, 9. That is a point for our graph. And what I'm going to do is I'm just going to get some other points here. For example, when I press 2, I notice I got 0 for the y, so that's going to be another point for our graph. Now that we see the overall shape of the graph, we need to write this graph down. One of the challenging things about this is not drawing the entire graph. We only need to draw the part of the graph which shows the football being in the air. So I wrote 0, 8, 0.5, 9, 1, 8, and 2, 0. I don't care about to the left of the axis, to the left of the y-axis because that's a negative time, and I don't care about below the x-axis because that would be underground. So I'm going to first label my headers here. Notice time is x and height is y, and I put an s after time because that's seconds and feet after y because that's height. I'm going to draw my axes on the side there. And I'm going to write the numbers 0, 1, and 2 because I know that the ball ends up at the ground after 2 seconds. I also need to write the word time in seconds. I'm also going to make hash marks and spread those out so I get all the way up to 9 since I know 9 is the highest the ball gets, and that's the height in feet. So I'm going to plot my 4 points, 0, 8, 0.5, 9, 1, 8, and 2, 0. And I'm going to try to sketch a parabola that is curved downwards, concave down. If you're having trouble lining up your points, it might be because you miscounted, so make sure you double check that. Now we're going to try to answer our questions. So what was the height the ball was released? That is shown right there in the graph and there in the table. That's 8 feet high. What is the highest the ball gets? It gets up to 9 feet tall because of the height of the point and the y value in the table at that point. That's the largest y value. When does the ball get to that height? It gets to that height at 0.5 seconds. That's because 0.5 is in the table next to 9 and 0.5 is the x value that's associated with that vertex. How long before the ball hits the ground? Well, when the height is 0, the time is 2, and that also shows up down there on the bottom right. So that's after 2 seconds. Now, how far from the thrower does the ball hit the ground? This is a question we were able to answer last time because the x represented the horizontal distance. However, this is time. It's no longer the horizontal distance, so we actually don't have enough information. So you need to write not enough information. It's very important that you distinguish and recognize what your input is because sometimes you can answer that question, sometimes instead that represents time. All right, thank you for watching.